So, homework assignment for today was to create a function that will convert a number like 123, so something like this, into the number 123, right? All right, so def, let's call this num convert, takes in a def string and returns base to decimal def string 10. Done. Wouldn't you say that that number is a number representing a base 10 number?
Yeah, it is.
So if I were to pass that to base to decimal and say that's base 10, would it give me the number 123?
Oh. Yeah. Yeah, but that was really simple.
You already wrote it. You already wrote the program. You just had to call it the right way.
Oh.
I mean, otherwise, what's? I mean, if we're gonna write this out, I mean, you're gonna see there's huge similarities in the code, right? So you can do something like, so we're going to need to keep track of sum. We're going to need to keep track of place. We're going to start at the end of that guy. So for I in range, length of def string -1, all the way up to, but not including -1, step by -1. Each time through, we'll say sum is equal to sum plus the int version of def string at bucket I. And this will work because we know we're dealing with just 0s through 9s, right? We could use normal int. And then place is equal to place times 10. Return sum. Doesn't this look pretty similar to this?
Yeah.
With the exception that instead of base, we just hard-coded in a 10.
Yeah.
And instead of char to int, we just use int. Why was I able to use int here, but I had to use our home-brewed char to int up there? What did char to int do for us? Go ahead.
Didn't it convert the string into an integer? Right?
Which aspect of the string? What did it specifically let us do for our strings? Give me a little bit more. Go ahead.
It allows us to perform mathematical operations with them.
Okay. So it gives us the number version of it.
Converted the letters.
Yeah, it helped us with the letter part of it, right? So int will work on 0 to 9. This is the built-in dude, 0 to 9, no problem, right? Okay. But if we pass it an A or a B or a C, we really want a 10 or an 11 or a 12, we had to write our own little function to do that. So this guy wouldn't work for that. But for this homework assignment, this would have been fine because we know we're only giving it base 10 numbers. So like 123, base 10 numbers only contain 0 to 9. No letters, so int works. That make sense? All right, so this is code for converting a decimal representation, so a base 10 representation of a number as a string, into the numeric representation of that string. Or if you just want to be simpler about it, just call. Here, I'll just write a second version of this. Num convert 2. Base to decimal, passing it def string, and saying that's in base 10. That make sense? You already had the tool. So this was one of those examples of you need to solve some problem around the house, and you are looking for this really weird specialized solution to the problem when you have like the perfect tool sitting in the toolbox that already solves it for you, as long as you use that tool the right way. Go ahead.
Will the function still recognize the base even if it's not in like the definition of it, since you just have that string in the first part?
Yeah, well, I'm not taking in a base here. Instead, I'm just assuming the base is 10.
Okay.
Yeah, this guy here assumes I will pass it 2 parameters. A string representation of some number, as well as what base that number's in. So I'm passing this guy the string representation of my number, which I know is in base 10. And then I'm just saying, by the way, that's base 10. All right, so we can test this real quick. Num convert to, we'll say 123, and then we'll print out answer. So there's our 123. Now, to prove to yourself that this worked, that you got the numeric version, you might want to go ahead and do, maybe add a 1 to it. Okay, and you expect to get a 124, right? 123 plus 1 plus 1 is 124. So there's our 124. That means that what this dude produced for us was a mathable thing. It's an actual number that I can do math with. All right, make sense?
Yeah.
All right, if we call num convert the original. Oh, do I not return? Sum is equal to int string at bucket I. That's right. Oh, I need to pass this guy. This is times place, right? Well, that. Oh, this is equals. So there's our 124. Okay. Or we had already debugged that guy, so just use the function that you already wrote previously. Okay, so let's talk about some new stuff today. I'll go ahead and put this stuff up on Slack real quick. All right, so I'm going to go ahead and gut this. Let's say I have a string like s is equal to hello, and I want to build that string in reverse. So I want to have a function that will produce that. All right, so we're already used to that tool that goes from the end of a string to the beginning of a string. Right? How do we build up strings? We use concatenation. So we have a tool that allows us to glue characters together to build new strings. Oh. So we'll just write this above it. So we'll say def reverse string. This will take a string as a parameter. You can name it whatever you want, but I just called it S. And we're going to go ahead and we're going to create a new string that I'll start off as the empty string. So usually when we're building up a string, we will start with the empty string and then tack things onto it, concatenate things onto it. All right. Then I'm going to go from the end of my string to the beginning. So for I in range, length of S minus 1, that's the last legal bucket of S, up to but not including -1. Take steps by -1, and I'll say answer is equal to answer concatenated with S at bucket I. Ultimately return answer. So if we print out S here and then we print out reverse string of S, we should get hello, then however you pronounce the hello in reverse. All right, so this takes us through a string. What's interesting here is what I want you to focus on isn't so much what the problem we're solving is, but the pattern. We are starting with an empty string, and we are building up a new string. It just so happens that the new string we are building is the string that is whatever was passed in reverse. Okay? Now, in this case, I'm actually walking the string that was passed in from the end towards the beginning, taking steps of -1. Now, I can write this an alternative way. I can say def, we'll call this reverse string 2. It'll take an S. I'll still start off with a blank canvas for growing, for building my new string. And then I'll say for I in range 0 to length of S. So this is our standard go forwards loop, right? And each time through, I'll say answer is equal to S at bucket I concatenated with answer. So now if I call reverse string 2, oh, didn't return, thank you. You get it in reverse as well. So what did I do? What's the difference between these two? In this one, I walked the string from the end towards the beginning and built it forwards. In this one, I walked the string from beginning to end, but I built it backwards. I tacked on my character before the current version of answer. So these two functions do the identical thing. I just accomplish it in two different ways. One of them I walk backwards. I mean, we couldn't put those patterns together and get it to work. So if I said I want to tack on S at bucket I onto answer here, then I'm just going to get the original string. I walked it in reverse and built it in reverse, giving it to me forwards. All right, so a couple different ways you can accomplish that pattern of doing something in reverse. And you want to think about when I'm building up an answer, you do not have to put, this is kind of our common pattern. We'll say whatever my canvas is, I'm going to set that equal to the current version of my canvas with a little bit more concatenated onto the end. In this case, what I'm saying is I'm going to say set my canvas equal to my new stuff concatenated onto the front of whatever my canvas currently says. One's not better or worse than the other. You just need to make sure you're using a compatible loop for what you're trying to accomplish. Make sense? Okay, so what if we wanted a function called remove vowels? So our vowels are A, E, I, O, U, right? Okay, so and we're going to forget about that whole sometimes Y crap. All right, so we have A, E, I, O, U. Those are our vowels. And we're going to take in a string S, and I want to remove all the vowels from it, returning a new string that is the identical to S, but with no vowels in it. How would you accomplish this? Just out loud as a human being. How would you look at a string and remove all the vowels from it?
Go each character by character and check if there's a vowel. Yes.
Okay. How do we ask if a character is a vowel?
Use if statement after defining A, E, I, O, U first variable vowels.
Okay. So we're going to have to check against the collection of vowels. All right. Now, real quick before I do this, I know a couple of you use this for your homework, but I want to test something real quick. So I want to make sure this does what I think it does. I think it gives you the position or a -1. Yep. Okay. So I'm going to give you a new tool. We effectively wrote this last class. When we wrote the function that will search through a string and tell us the position where something is found in there. We found the A at bucket 10. We found the 7 at bucket 7. Remember that from last class? So there is a built-in function in Python that, did the book introduce find yet? Okay, well, I'll show it to you anyways. Call this guy new tool, find. So find is a string function that takes, I'll go ahead and give it a, that takes a search string and returns the first position in what's called the calling string, where that search string appears, or a -1 if it is not found. All right, so if I had the string S and this guy was hello, and I said S dot find the H, the first place it finds the H is at bucket 0. It's going to return a 0. If I say S dot find the L, there's 2 L's in there, but the first one is at bucket 2. There's an L at bucket 2 and at bucket 3. This guy should return a bucket 2. Let me just confirm that's how this works. It should be how it works, but just before I advertise it, yep, the 2. Okay. If I say S dot find something that is not in that string, I'm searching for it, but I don't find it, it returns a -1. I'm going to put a little comment out here. Don't discount that little -1 thingy. That is a pretty powerful tool because it allows you to decide if something is not in a string. Make sense? This allows you to search for a string. And when I say up here that we're the calling string, that is, so the string we're searching is the string that is calling the find function. So this is a function that belongs to strings. So I'm saying S, I want you to look within yourself for this character. There's also a version that works for strings. And return the position where you first locate it, or -1 if it's not there. Makes sense how that tool works? So I ran over to Home Depot, picked up a new tool. It's equivalent to what we wrote last class, except we didn't do the -1 thing last class. Okay, we just said, we know it's in there. We had 0 through 9, A through Z. We knew we were only passing at those things. So we're going to just call that good. Okay. So we come back to this. Oh, taking less time to just rewrite the thing. Okay. So we're going to write a function called remove vals. And the job of this guy is to return a new string that is S with all of the vals removed. That's our goal with this guy. How might you go about that? So he mentioned that we need to go through every element of the string, right? Now are we building up a new string? Okay, well, let's go with this route. So we're going to say for I in range, and we're going through the string forwards or backwards? Forwards. We don't need to do anything special. It's not a reverse thingy here, right? So for I in range 0 to the length of S, not including the actual length, and that's how this guy already works. And then you said I wanted to ask a question each time through. What question am I asking? If it's a vowel. How do I ask if it's a vowel?
First, I would assign a variable to equal each vowel, and then ask.
All right. What kind of variable are we? How are you representing the vowels? Are you going to say like A is equal to A?
Yeah.
E is equal to E, like that? Okay. And then you're going to ask like a monster question. If what I'm looking at is an A, do this. If what I'm looking at is a E, do this, so on and so forth. Okay?
Kids do what we've been doing for the past couple homework assignments, is use a nested loop and ask if it's in this index. If it's not, go through the entire loop, and there wasn't a vowel, then the first loop.
So have another loop inside of this loop that goes through all the possible vowels. Okay? Is that all our vowels? Lowercase and uppercase? Could I ask the question in here? If. Now remember, I am wanting to remove vowels, correct? So let's start off with this. If map dot find, I am searching my string called map for S at bucket I, the current character I'm looking at. If that guy gives me something greater than or equal to 0, that means it's in there. Right? And if it's in there, I want to remove it. How do I remove it? And whenever I ask questions, I'm always asking them in terms of the things we've learned in class so far.
Okay.
So I'm not asking you to invent some thing, or if you saw something on Google or something like that. Only what we've discussed in class. Could I remove something from a string? Can I build new strings?
Yeah.
Could I possibly go through and build a new string and only keep things that are not vowels? So instead of saying, is this guy a vowel, could I really ask a question, is he definitely not a vowel? How would I ask the question, is the character I'm looking at not a vowel? Yep. If map.find this guy is equivalent to a -1, I searched for the character I'm currently looking at inside of my list of vowels, inside of my string representation of vowels, and I didn't find it. So the current guy is not a vowel. So this guy will fire true if the dude I'm currently looking at is not found in my collection of vowels. So if I want to rename this guy a little bit and call it vowels like that, maybe that's a little bit better name for it. So if it's not in my collection of vowels, I want to keep it, correct? Well, what does it mean to keep it? I'm probably going to be building up a new string. So if I did not find it in there, I'll say answer is equal to answer concatenated with S at bucket I. I'll keep it. If it was in there, I'm just skipping past it. I'm not keeping it. Does that remove vowels? Here's all my possible vowels, lowercase and uppercase. I gave myself a nice canvas to build up, a place where I'm going to keep all of the non-vowels. Instead of removing vowels, I'm keeping non-vowels. Make sense? All right, so I just kind of restated the problem in my head. So this is my canvas I'm going to use to keep the non-vowels. Here's all the guys that I want to not keep. In this case, I'm not keeping vowels, but I can say remove, we'll see in a second, I can say remove digits. All right, And this is going to go through, build up a new string, keeping only things that were not found in vowels. Okay? So, if I want to print, let me show it to you this way. If I want to say hello dot, actually, it's kind of a, I'm going to do it this way first anyways. Hello dot find H. Is that legal? Up to this point, we've always said like S is equal to hello, and then print S dot find H. Are we allowed to do this? At the very least, it looks weird. What kind of animal is that? It's a variable, right? What do we do to variables at runtime? We have to get the values in it. We resolve the variable. So at runtime, what will that S turn into? When we resolve that variable, it will become the value it currently contains. Now they look very similar, don't they? This first line is perfectly legal. Nothing wrong with it. Nothing says you have to have a variable to call a string function. You just have to have a string to call a string function. Make sense? All right, so this is perfectly acceptable. The only thing we might say is that you need a variable if you're going to need that value more than just this one time. In that case, you might want to put it in a variable. So same thing's true here. If I want to go ahead and I want to test my remove vowels, so I'll test remove vowels. I'll go ahead and pass it S here, but I'm just printing the answer here, which should be hello with all the vowels removed from it. So there's the HLL. But at this point, after that line of code, I no longer have access to that answer. I ran that code. This guy boiled down to a value, which was HLL as a string, and all I did was print it. So after this line's over, I've lost the HLL. If I want to keep it, I can say something like answer is equal to that guy, and then I can print out what I kept. And now I still have access to it. I can do other things with it and call reverse on it and that kind of stuff. Make sense? Yeah. Okay. Now, I can make this even more generic. Because right now I'm saying remove vowels. I can say, maybe we write a function here called def remove what do I call it? Remove from collection. We'll call this guy orig string, and we'll call this guy the collection. And now we could say answer starts off as the empty string. We already have, so what used to be vowels is now called collection. So we'll say for I in range 0 to length of orig string if collection dot find orig string at bucket I, if that guy is equal to a -1, meaning we did not find it in there, we will keep it. Answer is equal to answer concatenated with orig string at bucket I. Ultimately return answer. So now I have a generic form of remove from collection. I can pass this guy any collection I want. So what happens to remove vowels? Steal this real quick. I'll return remove from collection, passing it my original string and that collection. I want to remove from this guy all the values that are in here. Still get the same result. But now that also then allows us to write other simple ones like define remove digits, S, which is going to return remove from collection, pass it S, and pass it all the digits. So now remove digits, if I just sprinkle in some spaces in here. Now I'm left with the parts of it that were not digits. I should note, though, that there is a, notice there's some spaces in there, because we kept spaces. Those are not digits. If I want to also get rid of the spaces, I'll just can throw space in my collection. Now we'll also get rid of the spaces. So all I'm doing here is I wrote a generic form of remove this stuff from this guy. And now I can use that for all sorts of different functions, or even use it directly. I mean, I could just call remove from collection directly out here, right? Well, we'll use this one. I could say answer is equal to remove from collection, passing it S, and then passing it my, collection. Or I can have these little convenience functions that don't make me have to type in all the vowels or all the digits or all the consonants, stuff like that. All right, that makes sense? All right, so let's just go back to where it was like that, and I'll take this space out. All right, so what I'm going to do is I'm going to go ahead and give you this code. Let's say that I had a expression that looked like this: 123 plus 8 minus 2 plus 114. Okay, so a little math expression. You can assume there's no spaces in it, and the only math we can do is positives and negatives, addition and subtraction. Okay? Now, as a human being, you would look at that and say, oh, well, this is the number 123. I'm adding 8 to it, subtracting 2, and adding 114. And because we're just doing addition and subtraction, we don't have to worry about any of that order of operation stuff. Everything's just left to right. All right? So the answer we should get from this guy is 243. All right, so if I have a function, def process expression, and this guy takes an expression in as a parameter, And down here, I say answer is equal to process expression, and I happen to pass it that we'll write the expression on a separate line, and I'll pass it that expression. We would expect, when we print out answer, for it to give us, what was the number, 243? For it to give us 243. Make sense? That's what we want it to give us. So we need to write a function that does the math contained within EXPR, assuming only addition and subtraction are supported, and there are no spaces. All right, make sense? So now let's talk about at the high level, how do we accomplish that? So if I take in something like 123 plus 8 minus 2 plus whatever I said, something like that, how do you go through that and process that expression so that you can ultimately do the math? Go ahead. Using only what we've talked about in class.
You have to convert each of those into an int. You can't do math on that right now. So those have to be ints.
Okay, so this isn't mathable, first of all. So I'm going to need to get the number 123. I need to get the number 8. I need to get the number 2. And I need to get number 111. I also need to keep track of the math I'm doing. Correct? Okay, each time through. Now, it should work on things like that. I never hit a addition or subtraction. Just hit the end of the string. My answer should be 123. Right? How do we process this? We're probably going to go through the string one bucket at a time, right? Forwards. So we can say walk the string forwards. Now as I walk the string forward, so I'm starting off here. I'm at the very beginning of the string. When I get to that 1, what am I going to do with it? And then the 2, and then the 3. I want that whole number, correct? So somehow I want to collect that whole number. So collect digits until we hit a math operation or the end of the string. So in this case, I collect a 1, I collect a 2, I collect a 3. Now if I'm going to collect something, what am I going to need? I'm having to remember the 1, remember the 2, remember the 3. I need a variable. All right, so collect digits in a variable until we hit a math operation. So maybe I have something called curnum. Curnum's a string, and maybe I collected the 1, then the 2, then the 3. So that's what curnum currently looks like, something like that. So as I walked through here, I collected these guys, concatenating those characters onto a string. So far, so good. Then I either hit the end of the string or I hit a math operation. In this case, I hit a math operation. Now, so I hit the plus sign. Can I actually do the math yet? Nope, I need the other number. So when I hit a math operation, either a plus or a minus, and you can assume that's all that's in there, only legal inputs, then I need to remember that math operation so I can go back and do the math later on. Right? So I'm probably going to have to keep track of an op. Like that. Then I'm expected to hit numbers again. That is, collect digits in a variable until we hit a math operation. Now, I need a second variable though, don't I? Okay, so as soon as I hit a math symbol, I might want to transfer my current number into a new variable and then empty this guy back out so I can collect again. Make sense? So as soon as I hit the math operation, I'm going to store it. I'm going to copy this guy into a separate variable so that I can start collecting my next guy. How do I collect this guy? So when we hit an operator, record it, and move current number to another variable and empty current number so we can collect the next one. Then I start collecting again. I'm going to get an 8 here. But now I hit a math operator. Now right now it says when I hit an operator, I'm going to record it and move the current number. But I can only record it. So when we hit an operator, I'm going to kick this down a line now. If I do not currently have an op, then record it and move current number to another variable and empty current number so we can collect the next one. If I do currently have an op, I need to perform math. All right, now what's the math that I'll perform? The math I'll perform is the integer version of that number plus the integer version of that number. Convert both numbers to integers, so both string numbers, and do the appropriate math. Store the result in prev number. So that's the same second half of move current number to another variable and empty current number so we can collect the next one. Because I know after I hit this operator, the very next thing I'm doing is collecting another number. So I need to have a nice open container for collecting that other number. All right, so that's why I'm going to store my answer inside of prev number. So in this case, I would have a 131 inside of prev number. So I had to convert it back to a string, right? And then I'll empty this guy back out. Then what do? I read in my next number, 2. At this point, actually, I got to remember if I do have an op, I need to record the op. So after I've done the math with that plus sign, I can record that negative sign that I just read in that triggered me to do that math. So now, when I hit this 2, I build it up. Now I've hit another operator. Do I currently have an operator? If I do not currently have an operator, I do certain things. But I do currently have an operator, right? So I do this stuff. Convert both strings to numbers. Do the appropriate math. So I'm going to do 131 minus a 2. So you got to make sure that you do the correct left-hand side of the operation and the right-hand side of the operation. So this will take me to a 129 stored here. Then empty out that guy. Then record the next op. Collect, collect, collect. So we need to update this then when we hit an operator or the end of the string. So we make sure we do the final math. So now I build up that 111. I hit the end of the string. I do currently have an operator. I add those two guys together. 129 plus 111 is 240. Store the result there. And I can sit there and, you know, empty that stuff out if I want. Doesn't matter. When all is said and done, final answer is in prev num. Go ahead.
For the operators, if they're in strings, do we have to convert them somehow to not integer?
No, you'd probably ask the question. If it's a plus sign, do addition.
Okay.
If it's a minus sign, do subtraction. You'd probably just ask a question.
Okay.
Yeah. To your point, you cannot convert the char plus to the math operation plus.
And in Python, can you just say do addition? Like, how would you?
Well, you would say, you would get the 123, you would get the 8, and you would say, you had those two numbers, you would just say 123 plus 8. Yeah, just normal addition, nothing special, no fancy function. Make sense? So this is the algorithm for completing your homework assignment. So your homework assignment is to write this function. Make sense? All right. I will see everybody on Monday.